I'm back, and I decided to go to the lake to record this video just for you guys. There you go. Okay, again, because of hydrogen bonding, water has a stronger resistance to temperature change than other substances. So if you live by the ocean, if you live by a lake, you will have less fluctuation in temperature. If you look at the temperature of, say, Miami compared to the temperature of Orlando, you will see a huge difference. Miami has a more constant temperature than Orlando. If you look at San Francisco versus Sacramento, that's a good one. If you look at some places up in Michigan, by the lake, farther away from the lake, there is a tendency of large bodies of water to regulate the temperature change and make fluctuations harder. Water resists the change in temperature. When water is heated, the energy is lost. It first disrupts the hydrogen bonds and makes the water molecules jostle faster. So here's what happens. You get some water, or you start with ice, right? Here's my condensation example. See the condensation on there? No, you can see it. There's condensation on there. See it? Condensation. How does that happen? So in this case, some water molecules were just coming along at a room temperature, smack, right into here. And they're like, oh man, now I've got to be a liquid because I'm cold and I'm moving slower. So it is effect of temperature. The effect of temperature is, if you're warm, room temperature, even water, you're going to float around as a air molecule at a certain temperature. At a cold temperature, like my glass full of ice, you're going to smack into this glass of ice. You're going to be immediately cold. And what's going to happen? You're going to turn into water. Oh, now I'm water. But what happens if I leave this on my desk overnight? Basically, what's going to happen is the condensation goes away. Where does it go? Where does it go? It actually just evaporates. The whole thing will warm back up to room temperature and it will move. So why doesn't my super fancy Starbucks cup do this? Why don't I have any condensation on the outside? Because there's a double wall. Basically, the idea of my fancy Starbucks cup is that there's a section keeping the outside from getting cold so that it doesn't have any condensation. No condensation. Does that make sense? This is also what you see with dew. The grass got wet and cold at the same time. So basically, or it just got cooler. The ground is cooler than the air. The air temperature hits the grass, and it's like, oh, now I have to become a liquid. And then throughout the day, it warms up, and those water molecules can become air molecules again. You don't have to boil them. They just evaporate naturally. You can make that happen faster by boiling them. Okay, so heat is the first way to break hydrogen bonds. Rather than raise temperature, water absorbs and stores a large amount of heat while warming up only a few degrees. This is how it moderates temperature. So before it goes ahead and freezes or releases as gas, it just cools it down. It just absorbs all. It will take days before this evaporates, right? I could leave it on my desk for at least a week before it's gone. It doesn't evaporate immediately, but eventually it will evaporate. But it will keep a solid temperature. It'll stay about room temperature in my office for days and days and days. It absorbs the temperature. When water cools, hydrogen bonds form, and that process actually releases heat. That's important. When water cools, hydrogen bonds form, and that releases heat. Why do we care about that? How does that relate to our lives? It's called evaporative cooling. Earth's giant water supply basically enables temperatures on Earth to stay within a life limit, storing huge amounts of heat from the sun, giving off heat that warms the air during cold periods. Evaporative cooling. What does this mean to you? Because you do it, friends. It occurs when a substance evaporates and the surface of the liquid remaining beyond cools down. Sweating. This is why going to the pool makes you cooler. It doesn't always work in St. Louis when the humidity is 85% because you're already just so humid that the water won't evaporate. But when you go to a pool and it is a reasonable humidity outside, the water evaporates off you and it pulls the heat with it. When you sweat, it pulls the heat with it. It pulls the heat with it. So you're actually pulling heat out of your body by sweating. That's how you keep cool. It's one of the ways that you keep cool. You pull that heat out because you create water on the surface of your skin, and then it evaporates and it pulls heat out with it. Not as effective when there's 85% humidity because there's already water molecules everywhere, so it can't really evaporate and go anywhere. When water molecules get cold enough, they move apart and form ice. Now, this is the opposite of what other chemicals do. When a chunk of ice floats, so my ice is actually floating on top of this. Right there. There's ice floating on top. Why is it floating on top? Because it is less dense. That is unusual. Remember, I said as they get colder, they get closer together. They form a bond closer together. So our air molecules are la 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 la, then they get closer and they form a liquid. Well, when they get all the way close, you would think they would get smaller, but they don't. They form a pattern and they get bigger. Does that make sense? When they actually freeze, they're not just close together. They're actually like, they make a pattern, and that allows ice to float. I realize you don't care about this. Who cares if ice floats? Why does this matter to anyone? I'm telling you, it matters for life on Earth. The fact that ice floats, kind of a big deal. Not as big of a deal for you, but a super big deal if you're an aquatic animal, right? Especially if you live in a lake. You want the ice to float on top, so it basically insulates you, and your little fish self is down here, or your manatee, or your seal, or whatever you are, and it keeps, first of all, we already know that water helps regulate temperature, and secondly, you've actually sealed off the top with the ice floating on top, so it kind of seals you in and lets you stay warm through the winter. See what I did there? Seal you in. When a deep body of water cools and a layer of ice forms on top, it's almost like an insulated blanket that allows the animals to live underneath and stay warm, and it can persist under that frozen surface. If ice did not float, ponds, lakes, and oceans would freeze solid. If it didn't float on top and then keep everything else insulated, if it froze from the bottom, everything would just be frozen solid. And your little fish self would just be like, oh, frozen. So ice floating, it's kind of a big deal. Okay, solvents, solutions, have a solvent, which is the dissolving agent. That is almost always water. Kool-Aid example, or whatever it is that you're drinking, instant coffee, water inside my cup. Solvent is the water. If I put instant coffee in here, if I put Kool-Aid in here, if I put Tang in here, if I put whatever, Gatorade, powder, that would be the solid. The solvent is water. Water is almost a universal solvent. A lot of things dissolve in water. There are things that don't, but primarily things dissolve in water. Sugar makes good sweet tea. Water can absorb an enormous variety of solutions. This is very necessary for life, and it provides a medium for all chemicals everywhere. When water dissolves salt ions, each ion becomes surrounded by a charged region, and we will talk about that. That is, here's sodium, here's a salt crystal, and basically that gives us acids and bases. Next video, acids and bases.